The other formula that goes closely with the midpoint formula would be the distance formula, and it's written right there. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And where that comes from, it's based on the Pythagorean theorem. So before we do some examples, let me just show you. Suppose you had a setup like this. Here's your coordinate axis, and let's say I had a point right here, and let's say I also had a point. Let me just expand that out a little bit. Let's say we had another point right here. And the question that we want to know is, what is this red distance right here? So why is this based on the Pythagorean theorem? Here's why. If you were to connect these points like you're about to see me do, okay, you might be able to tell that that looks like a right triangle, right? Here's the right angle. It looks like a right triangle. And the Pythagorean theorem says that if this is a leg, and we'll call that distance A, if that's a leg, we'll call that distance B. This is your hypotenuse, we'll call it C. The Pythagorean theorem says that A squared plus B squared equals C squared. If you want to solve that for C, C being that red distance right there, that red line, if you want to solve that for C, it's being squared right now. So you could square root it, and you would get C is equal to this thing right here, square root of A squared plus B squared. So you can see that looks kind of similar to this distance formula we have right here. You have the square root of two things being squared and then added together. So how does that actually come out to be the distance formula? Here's how we can say that that's the case. Um, let's call this point right here. We don't know what that point is, so let's call it. And actually, let's call this point something too. And obviously, the red one looks like it's at the origin. It looks like it's at 0, 0. But pretend we didn't know what it was. We could call it x and y because it has an x coordinate, y coordinate. We don't. At least we're pretending that we don't know what that is. Same thing up here, this other red point, we could call it also xy, but we'll call it x sub 2 and y sub 2 because it's a second unknown x and a second unknown y. So the question is, first of all, what would this green distance be right here, that A distance? Well, if you think about it, that green point right there, okay, it's on the same y level as this one. That red point and that green point, I haven't moved up or down at all, so I'm still at y1. But I have gone from this x value, that x1, over to that x value, that x2. So how would we find the distance? Well, I haven't changed my distance at all in the y direction. I have changed in the x direction, though. I've gone from a value of x1 to a value of x2. If, hypothetically, suppose that were 0 and suppose that were 3, because it looks roughly like that from the picture, what's the distance from 0 to 3? And the answer is 3. Okay, what's the distance from x1 to x2? The answer would be their difference, x2 minus x1. So that right there is equivalent to the A. So if we put that right there, we would have this. We would have the difference between x2 and x1 squared. And then by the same reasoning, this distance right here is the difference between y1 and y2. So we could add that into our formula, the difference between y2 and y1. And now we have the Pythagorean theorem changed around into the distance formula. Instead of calling this C, we'll just replace that with the letter D for distance. So that's where it comes from. You don't have to know how to prove it in order to use it, but it's nice to know that it does have a connection with something that we're probably familiar with from geometry. All right, so let's find these two distances here. So the first one gives us a coordinate, and it's saying find the distance of that black line. So that point right there, that bottom point looks like it's at 0, -2, and this point right here looks like it's at -4, +3. So now we need to use this formula right here. It says the distance is equal to the square root of our second x coordinate. Now it doesn't actually matter which one you pick. I'm just going to pick -4 as our second x coordinate minus our first x coordinate, minus x1. So there's x2, there's x1. You could reverse those and you would still get the same answer, so it's not important. And then that's supposed to be squared because that's what this is telling us. Plus, and then we have our y2. So here's our y2, and this is our y1. So plus the difference between 3 minus -2, and that's also being squared. All right, so now how do we solve that? Well, basically, we can just simplify that out. So if you simplify this, you're going to get -4 minus 0 is -4. And when you square that, you get +16. And then we're going to add 3 minus -2 is like 3 plus 2. So that's going to be 5 squared, which is 25. And that means when you add those, you get the square root of 41 as your distance. So that is how we would simplify. All right, this one's a little bit more interesting because it's a word problem. It says John lives in a city set out like a grid, and there's a lot of cities set out like that. You could you could use New York City as an example. Fourth Avenue is right next to Fifth Avenue, and on the other side is Third Avenue. So it's kind of set out exactly like that, exactly like a grid. So he lives in a city set out on a grid, and it's telling us something about the city center. So we can say the center of the city is right there at 0, 0. We'll say CC means city center. His starting point, so maybe he's at home. His starting point is 2 miles west. Well, 2 miles west would be 2 miles that direction, 2 miles to the left, and 3 miles north. 3 miles north would be right here. So that's going to be at the point -2, 3. That's 2 miles west, 3 miles north of the city. He walks 4 miles east. So if he walks 4 miles east, if he's at -2 and he's going east, east is this way. If he goes 4, 1, 2, 3, 4, he's going to wind up over here at +2. And then he walks 5 miles south. So right now he's at y = 3. He's going down 1, 2, 3. That puts him at 0, 4, 5. He's finishing right here at that point, and that is the point 2, -2. How far is he from where he started? So how far is he from where he started? That's another way of asking what's the distance of that red line right there. So see if you can pause the video and try to find that out. So his distance is going to be the difference in the x's. So there's our x2, there's our x1. So -2 minus 2 squared. And -2 minus 2 is -4. When you square that, you get 16. And then the difference between that and y2, which is right there, minus y1, which is right there. So 3 minus -2, and actually didn't intend to do that, but it turns out to be the exact same as our other answer, because that's again going to be 25. 5 squared would be 25, so it equals the square root of 41. And because we're talking about miles, you usually wouldn't say, hey, I walked square root of 41 miles. You'd probably say something like, I think that's going to be about 6.4 miles. So, by the way, when they're talking about distance, a lot of times they'll refer to that as distance as the crow flies, because if you were driving or actually walking, that red line is probably cutting through a whole bunch of buildings and other places that you wouldn't be able to drive or walk through. But that's the shortest distance, is that perpendicular, or that straight line distance right there. So that is how we use the distance formula. Hopefully it makes some sense.